more easily handle different types of syntax that you can throw at it. It's used for a lot of things, web apps, artificial intelligence, machine learning, and way more. All right. And also throughout this whole thing, if anyone has any questions, please feel free to just, bombard me, with any questions that anyone has, if that's fine. All right. And yeah, so again, let's cover, whoops. Give me 1 second. So we'll cover the basic topics: variables, loops, functions, and running your program. So if anyone doesn't know, variables in programming are used to store data. So there are different data types that you can store. They can be integers, strings, and floats, and more. And variables are used to store them. It's kind of like doing algebra, but in a IDE instead of on a math paper. Then we'll talk about loops. Loops are things that allow you to repeat processes many, many times over and over again. So for example, instead of printing a certain number 100 times, you can write a loop to iterate from 1 to 100 and then print that number. A function, again, it's just like algebra, is something that takes an input and gives you an output. So that function is a process that you can then call many, many times. So if you wanted to write a function to calculate, the square root of a number, you could just call square root of that function over and over again. And we will run our program in the glitch coding environment just now. And I think that we are here. All right, so let's get it set up with glitch. So if you've never used glitch before, which is like an MLH sort of product, we're just gonna set that up really quick. But it's gonna be super easy. For me, it took like 30 seconds, so don't stress too much about it. So we're gonna use this URL, and I think I'll have to change to my PowerPoint. And I'll just paste this in the, I'll paste this in the Zoom, so don't stress too much about this part. Right. Let's see. Still sharing the screen. Okay. All right, now that we have that, let me paste that in the chat. Oh, you can use your own IDE. There are just some exercises that are on glitch already, so it's not a big deal. But here is glitch, so you can get signed up like that. And then at this link, which I also have to paste real quick. So this link is where our challenge exercises are located. So let me put that in the chat. There we go. So once you've signed up or into your glitch account and you're good to go, that second link, when you click it, you will see a screen that looks like this. So your screen will look like this. And then if you click remix your own, then it should take you to a screen that looks like, let's see. There we go. Okay. It should take you to, after you click remix your own and log into glitch, it should take you to a screen that looks like this. Let me just check that everyone is kind of on the same page right now. Anyone ever having any trouble getting into Glitch? So remix your own. Let's see if I can go back. When you, if you have this screen, after you do that basic training -I link, remix your own will be in the bottom right here. Giving an error on sending the email. Okay, so what you want to do is the first link that Hannah actually sent is for signing into Glitch. So that will let you log in. You just click sign up with email, and then you should be fine for creating an account with Glitch. It should create a page that looks like this. This one's throwing an error. So you're talking about the first link? All right.
Yeah, the first link's the one that's throwing the error for me.
Okay, that mlh.host/glitch.
Yeah, it's saying that the Google login problem, internal server error, or the email is not sending due to some error.
All right, and is that error throwing for everyone, chat?
I used the link that you sent and I got to like the remix part fine.
Okay, so some people are getting the error, some people are not. That is unfortunate. Maybe make sure, so when you do this link, make sure to click, and I would have to sign out to find this again, but make sure to click sign in with email. Like, I don't think you have to do, like, don't enter a password or all that stuff.
Quick question. Could you show, so my GitHub was acting up. I finally got to log in. Where do I go after I click the second link?
Right, so after you have your second link, you probably have a page that looks like this. I'm assuming, let's see.
Yes, I have the basic -training.py.
Got it. So once you have this page, you want to click remix your own. It should be right here, the bottom right. And then that should load some of these files. And you should see challenge, functions, imports, lists.
Yep.
And so on.
Perfect. Thank you so much.
Yeah, no problem. Okay. Share the link again, no problem. So I'll just say first link here, second link is this one.
Please, can you?
Sorry? Let's see if I can get this Slack message to go away. It's been here for a minute. It's fine. Okay, so I think we're probably going to move forward just now. If you're having problems, if you have an IDE, it probably won't be too hard to follow along. It's not super important that you use Glitch. It just has a little bit of code that's already pre-written. But okay, so now that we're in our Glitch environment, we can start writing code. So we want to start doing that with variables. And variables store data. So like numbers, text, they can store other types of data, but that's what we'll cover for now. So we can create variables by declaring them. And in Python, a variable declaration is done by stating variable name equals some value. So if we open variables.py in Glitch, we can try and do some variable declarations. And because, people have said that they have, for the most part, some programming experience, I'm not going to spend too long on this, but we can do things like an integer data type. So integer data type would look like is 5, where it's a countable number as an integer. We could have a float data type. A float data type is kind of like a decimal. So we could have something like this, where in Python, if you just add, 0.0 or something like that, it would give you a float. A string in Python is given by quotes. So a string is like a word, a sequence of letters. So word. And all you have to do is just add quotes or some, brackets around it, anything like that. And we can always print these things. So, oh, they already had these. Well, that's fine. And you can print out these variables so you can just make sure that you know what you're looking at. So for some of the example code, they have, different ways for printing these statements. And print statements in general are like super useful. So we can, print word. We can print, if we want to say, I am 5 or something like that. Python has a bunch of pretty useful tools for, integrating these kinds of things. So we can say something like this, and that'll give you I am 5. And to run this, by the way, just to run your glitch programs, go to Tools, Terminal, and it might take a little bit to load. And then if you type in Python and then the name of your file, you should, boom, return, whatever you want. Wow, okay, well, that gave a tuple, but that's fine. So yeah, I'm not going to spend too long on variables. Just making sure that there are no further questions. Okay, just some more link questions. Okay. Our pictures might have looked a little bit different. One other cool thing that Python supports is like comma variable declaration or tuple variable declaration. So just a cool nifty trick that you can do is say something like A, B, C is equal to 1, 2, 3, and that should assign A, B, and C to 1, 2, and 3. So if we print A, B, C, and this is just something that you can do if you ever need to, like, I don't know, declare or assign a bunch of things in, one big thingy. All right, so that's variables. I think most of us probably have some grasp on variables. Again, if you have like any further questions or stuff, feel free to shoot away in the chat. Yeah, this just covers some of the glitch stuff, and of course you can reassign these. So using any mathematical operators, you can change these variables. Like you can say num is equal to, yeah, this is definitely something I should cover. So let's say we wanted to change the values of these variables. We can reassign num to be 3, for example. So that's just a reassign, and it overwrites the previous value. We can even use num to reassign our value. So we can say num is equal to num plus 1. And that would reassign our variable value to 6. We can just check that. And this is a super useful tool for things like incrementing, making counters, and all sorts of like useful stuff that we'll use in Python. All right. Then, yeah, and we can do this for all strings decimals, or strings, floats, numbers. One other interesting thing to know about Python is that it's not a very strongly typed language. So in C++ or Java, you will have to declare your variables as having a type. So an int must stay an int, a string must stay a string, and so on. But in Python, this isn't necessarily true. So we can actually reassign decimal to be equal to 5, or decimal to be equal to even word, and the interpreter won't have a problem. And that's one of the advantages of Python being an interpreted language, is it's kind of not so rigid in its ways and set. However, it is bad practice, so you probably should try and avoid this, but there are circumstances where that may be needed. All right, so I think that for the most part covers variables. If anyone has any questions about variable declarations and stuff, feel free to let me know. So for people who may have trouble with glitch, for a lot of these, I'm kind of doing them from scratch. So if you just follow along in an IDE, if you have an IDE, that'll be fine. But yeah, maybe there are some problems with glitch just now. I'm not super sure. Okay. All right, let's move on. I kind of forget the sequencing of these things. So yeah, functions. Functions are cool. Functions are super useful too. So a function lets you reuse a block of code over and over. In programming, you don't want to write the same piece of code way too many times because that's just inefficient. It'll bloat your code. It'll make you mad. Copy and pasting is not super fun. So a function is called using the parentheses. So anytime that you have these two parentheses after a word, you're probably calling a function. And these are built-in functions that we're using right now, like print. And let me hop over to functions.py. So these are built-in functions that we're using right now, like print, hello, print, goodbye, stuff like that. But we can actually define our own functions, which is really important. In order to define a function, we need what you would need to define a function in math class. So you need to know what your function is taking in and what your function wants to spit out. So there should be an input and an output to your functions. And what we call is the input is the parameters for a function. So a function will take in certain parameters and a function will output a return value. So in Python, the syntax for defining a function looks like def, and then we can call our function, we can just call it, let's see, I'm kind of following along. I want to use the same example as they do. Yeah, sure. So something like say hello. So if we want to print, a modified string, then we want to take a string as our parameter. So maybe take someone's name as a parameter. And just for showing what we can do with some variables and some Python syntax, we can call it output is equal to hello plus name or something like that. And that will allow us to then return this output. And when we print, say hello, Bob, or something. And we run this code. Functions.py, we'll get hello, Bob. So this is an example of a function. And now anytime that you want to say hello name, you won't have to type this anymore. You just have to type say hello. And I mean, for this function, it might look kind of dumb because, what's the point of just saying hello, Bob? But it can be really useful when you have a really complicated task, but you want to, minimize how many times you repeat it in your code. So that's a cool thing about functions. Another interesting thing about functions that I didn't know for surprisingly long, but can be done, is functions can actually be passed in to other functions as parameters. So let me come up with an example for this really quick. But essentially, let's define two functions, add1 and add2. So add1 for some number will look something like this. So we can just return num plus 1. And if I'm going too fast, please let me know, or like, if anyone has any questions, just let me know. Add2 can look something like this. And what we can do is say, we can define a third function. And just to be clear, these two functions, add1 will add 1 to an inputted number, add2 will add 2 to an inputted number. And we can define a third function, and we can call it adder. And what adder can do is it can take two parameters. It can take a function as a parameter, so we can call that f, and it can take and I forget the syntax, I might need like f parentheses or something like that. And it can take a number as a parameter. And essentially, you can return f of that number, and we will specify the like function value in the function call. And by the way, when I do something like this, when I say hello of Bob or say hello of this, that's called a function call. I'm just looking. Oh yeah, the terminal. It can be kind of weird, tricky. Make sure you do terminal though and not console. That was a mistake that even in the tutorial, they were talking about doing console instead of terminal. Right. So let's see. I actually don't know. I feel like you might have to use brackets over here, but let's see. Adder, so let's try add1. And then, I don't know, 4. Python functions.py. Okay. Oh, well, I need to print this. Yeah, sometimes that happens. You just forget to print stuff. And we can comment that out. All right, so yeah. Does everyone kind of follow what these three functions did?
Sorry, the last one I don't really understand. The adder.
For sure. So what add1 does is it'll add 1 to a number. And then what add2 does is it'll add 2 to a different number. So adder is kind of strange in that it takes a function, which I call f, as a parameter. So it can take add1 or add2 as a parameter and then call that function on the other parameter, which is a value. So right now we used add1. So what adder will do is return add1 of 4. And then we can even change this to add2 in our function call. And it should return 6. Yeah. This is like a nifty feature of Python, or just a nifty feature in general. That honestly, I didn't know this functionality. Like I never used it for a long time until someone showed it to me. It blew my mind. And this can be kind of useful in like, you know, a scenario where you have to kind of switch whichever function you're using depending on a given condition. Add2 of 4. Can you just print add? So yeah, and this, these are like kind of simple cases. That's not, it's not super, helpful to use the adder. But if you imagine a situation where you need a different function to handle, a different case, right? So maybe if your input looks like this, then you want to use this function. If your input looks like this, you want to use another function. And you have a bunch of different functions. You can actually write a function like adder that will take an abstract function as a parameter and then pass it through. But this is again, some sort of like Pythonic sugar that isn't super critical to what you need. So I'll say below this is for fun, but here are the important parts, right? When you declare a function or define a function, in Python, you want to say def, your function name, which is like F, G in math or stuff like that, and then your function parameters. So these are the things that you're passing into the function. And then in Python, you need a colon to define your function. And then you need to indent everything underneath that function. So these are, and finally, every function needs a return value. So what are you outputting from that function? What are you returning? These are like the critical components of a function in Python, and like basically all of the Python code that you're going to be writing, period, is going to be in functions. So in machine learning, when you want to train a model, build a model, clean data, if you use good programming principles, then you will have functions that handle all of these. So Python is actually a little weird about void functions and passing things by reference. And it's a little bit trickier to have functions in Python that don't return anything because they don't pass. Python doesn't support passing like lists and values by reference. We won't get too much into that right now, but yeah, as long as you remember these three components of functions, and the fact that you can call them, and you don't need def to call them. You can just simply say function name parentheses parameter, and that's good enough as is. All right, I spent a little bit on functions there, but I think functions are super important. So yeah, and if anyone has any more questions, feel free to ask, because that's like a super core concept to Python. Yeah, okay, all right. Yeah, I'm kind of not like super following along what the slides are saying, but it's fine. Right, and we can also pass in multiple parameters. I kind of jumped the gun on that one with this, but just so you know, you can pass in name, last name, and then you can do something like this. And then that should print someone's like full name. Bob, I don't know what, I can't, it's too much pressure to think of a last name. I don't know. Okay, hello Bob. So you can pass in multiple function or multiple parameters. Right. Yeah, okay. Does anyone know how to do this? You can just type it in the chat. And this will start to get into operations, which are also a core Python feature that is like super important, dynamic in Python. Can we do something with input function? Yeah, it'll look something like that. Return our first number times our second number, which kind of brings us to operations in Python, which aren't covered like super thoroughly a lot of the time, but
wouldn't that require like an input? Us to do it like an input, like two inputs, you know?
Right, yeah. So to multiply two numbers, you mean?
Yeah, like because you said define multiply, so it would require like you inputting like if you put return num1 num2, so wouldn't that be you have to put input num1 num2 and then and that's just
Right, okay. That's a good question. So in a function, here, let me remove these lines. I believe you're talking about something like this, right? Where you call input like that. And then basically this is asking the user for like standard input. So then the user can then, in terminal, say, set the value of A manually. And then you would multiply those two numbers. But actually in a function, that's not entirely necessary. So, if you wanted to multiply two numbers, you can have your two parameters in the parameter part of the function. So num1, num2, and then you can return num1 times num2. And if you want to, talk about using standard input in Python, you want to set like maybe A equal to input and B equal to input or something like that. And then you can then call, multiply on A times B. Or if that was your question, like you want to use user input to get like a certain result. It's actually been like a hot minute since I've used any input in Python, so.
Yeah, thank you.
Yeah, so I had that misconception too when I was starting programming, that for any program I would need like this input to get input from the user, but that's not always true. And like in the programs that you're probably going to be writing in Datathon, you probably won't need to use input too much because you're going to be working more directly with like the code than you will as like a user on the terminal. So yeah, I hope that answers that question.
Yeah, thank you.
All right. Okay, we spent a hot minute on functions, but hopefully all good. Right, so we covered this. Okay. Right. And return values, one other thing, we're still on functions. One other thing you should know about return values though, is that you can return multiple values from a function. So this is like super useful in a lot of cases where your function will produce a lot of different data and you want to return all of that data. So like maybe we want to return like a certain number, goodness, and maybe we would want to return that number plus like a bunch of stuff. We can return num plus 1, num plus 2, num plus 3, and so on. And then in our function call, we can integrate this with the variable declaration stuff we learned from earlier. And let's say we want to say A, B, and C are equal to these three return values. We can say something like this, return many of like 5. Then we print A, B, and C. That'll give us like 6, 7, and 8. So we can always return many values from a given function. So don't feel too constricted that each function has to return one value. Okay, now let's actually get off of functions. Oh my goodness. All right. Yeah, we know how to. And here's one more thing you should know just about Python in general. There are a lot of really cool built-in functions, upper, lower, that can change the case on a given string. So if you do like string.upper, it'll give you an uppercase version of the string, string.lower, and so on. And there's way, way, way more. Like there's a set function, tons of other cool things. A big part of, and Python is super well documented, so a big part of it is if you don't know how to do something in Python, just put it in Google, and I promise you someone has had that problem before. What are we thinking? Okay. Oh, right, block comments. Yeah, I guess I should cover commenting for a little bit. Oh, loops. Loops are fun though. And loops are where Python is really powerful. So let's get to talking about loops, and I'll cover commenting as well. So there was a question on how to do block commenting. So if you've noticed, if you do like hashtag or £, that will comment a single line. And then if you want to comment like a bunch of stuff, then you can do triple quotes. Enter, and then everything inside the triple quotes won't bother your program. Okay, now we can cover loops. Loops are fun. I like loops. So yeah, let's say you wanted to print days 1 through 10. So this is definitely a way to do that. So let's try it. I really should have turned my notifications off before this, but you know, that's fine. So this can print days 1 through 10, right? Makes sense. But what if we wanted to print days 1 through 100, or 1 through 1,000, or 1 through 1,000,000? You know, I just had to do some like computer science homework where I had to like process like gigabytes of data, and then I used a ton of RAM on my computer, and then it got really hot and it was really bad. And you don't want to have that many print statements because your computer won't be able to handle that file size for any like meaningful scale. So how can we kind of make this statement super concise? We can use a loop. And what loops are a very concise, easy to understand way for, you know, outputting or repeating the same process multiple times. So yeah, let's look into, yeah, it's just repeating the same task over and over again. And Python has a bunch of cool ways that you can use loops to make your life better and easier. So we can do the same process by something like this. So let's get rid of all that, print day 1, print day 2, all that stuff. And there are 2 kinds of loops that we can talk about. There are for loops, there are while loops. So I really think in Python for loops are just like overpowered. So let's talk about for loops first. So let's say we wanted to do what we were just doing, right? So we can make a for loop. And a couple things we'll need to know before making a for loop. Essentially, a for loop iterates through a certain range or range of values and repeats a task for each value in that range. So there's actually a range function in Python that you're probably going to use a lot, which is super handy for this. And I is usually the convention for the, you know, iterator of the for loop, though you can use anything. You can say num, really anything. So for I in a range, oh, and in is important. This is the kind of basic syntax for a for loop. And we want 10 days. So in range 10. And lastly, we need a colon, just like function declarations. And we also need to indent our body of the loop. Now, what we wanted to do was print what days of, what was it? Oh my gosh, day, and then the number. So we can do this by using our print function, print day, plus, I really should be using format strings, but I feel so much more at home just using plus minus. And this is something I should have told y'all in the variable section, but I guess I can say it now, is that you can actually convert between types in Python like pretty easily for the most part. So something like, I can use the comment block for this. Int, float, and str are your friends. Basically, if you call these on each other or on different data types, you can generally convert back and forth with some exceptions, right? You can't call int on like a certain word, right? That doesn't really make much sense. But if it's a string version of the word, or if it's a string version of the number, then you can call int on it, if that makes sense. But I'm just going to demonstrate for now. So string I, and this will actually not give us the return values we want, but that's fine. So this gives us the same stuff. The only difference, if y'all have noticed, is that instead of starting on day 1, it actually starts on day 0. And that's because Python is 0 indexed, which is super important. It'll come up everywhere. If you forget that, it'll cause a lot of problems for you down the road. That Python is a 0 index language. So the first index for every iteration or anything is always 0, then it's 1, and then up until, that value -1. So if we wanted to make this 1 to 10, does anyone know how we would do that? Leave that as an open question.
You would just, instead of putting 10, you'd put the value that you want plus 1, so it'd be 11.
Yeah, we could do 11. And then what if we wanted, so what this would do is it would still start at 0, and then it would end at 10. Do we know how maybe we could start at 1 instead?
Oh, so you do 1 comma and then the value that you'd like.
That's exactly right. So if we do something like this, and then run Python loops, we get our values. So the range function, again, there are other features, but essentially it can take in multiple parameters. So this is your start value, this is your stop value, and the range function also actually takes a step. So let's say we want to skip every other day. Then we have our start is 1, our stop value is 11, and then we can take a step value. And I don't know, I think that should work. Yeah, and now we'll skip and we'll only hit odd days. So range is super powerful, lets you do a ton of cool stuff. Yeah. Now, that's just the beginning when it comes to loops in Python. Python also has this cool feature. Maybe I'll cover this more on lists, actually. So I won't cover this so much for now. But let's handle while loops, because they're also a really important idea. A while loop, unlike a for loop, a for loop executes for a certain defined number of times and then it finishes. A while loop will continue repeating until a certain condition is true. And this operator right here is the Boolean equals sign. So it determines if two things have the same conditional truth. It will just execute some stuff. Now, where this can be useful is maybe we just don't want to, linearly iterate through things. Maybe we want a different break condition or a different place where we want to kick out of our program, right? So for example, maybe instead of iterating through stuff linearly using our range function, we want to do it multiplicatively, right? So maybe we want to print the exponential growth of something. So let's call our bound. This is just to demonstrate where a while loop might be useful. Let's call it 128, right? And we can say that our initial value will be 1, right? And then finally, we can say, while initial, which is our value of that we initially set it to, and we want to execute it or kick out of the loop when the bound has been reached, right? So we can use the Boolean operator not equal, which is a little exclamation point and then an equal sign, is not equal to our bound. So while it's not equal to our bound, we can do stuff. And maybe something that we could do, because I use powers of do, is say, hey, initial will be equal to 2 times initial. And what this will do is multiply initial by 2 every time. So yeah, let's just see what this runs, and we can print initial as we go along. All right, so we walk up in powers of 2 from 1 to all the way to 128. And again, this may not look practically applicable right now, but there are many times where we want to do stuff like this. And I guess maybe I should cover, here's a quick cheat sheet of like just operators that you might want to be aware of in Python. So we of course have addition, which is here. This is multiplication, which is right here. And this is all stuff you can, if you look up like Python mathematical operators or something like that, you can find it. This is division. This is, you know, subtraction, of course. And then we have some other cool operators that you can use. This is the power operator. So, and this is just stuff that makes Python super cool, is like the super concise syntax, right? So if I wanted to print like 10 squared, I could just do something like that. And yeah, that should just give me, you know, 10 squared. So this is like the power operator, the modulo operator over here, which if you're not familiar, it'll give you the remainder of division. So 11 modulo 5 would be equal to 1, because 11 divided by 5 is equal to 2, remainder 1, and so on. This is just cool stuff that I think, you know, everyone should know about Python and so on. You can look all of that up, of course. Right. Loops. So that covers, I think, most of what we need to know about loops in Python. We will definitely be returning to loops, though. They're super important. All right. KK. Sounds good. Okay. Yep. Lists. Lists, man. Let's go crazy. Lists are wild in Python. So a list is a data structure that we can use to store values in Python. And Python is pretty unique in that it kind of has this, I mean, lists are not the only one data structure that are in Python. There are more. But it's sort of unique in that there's just this one like super multi-purpose data structure that you can use to do a lot of different tasks. So if you're aware of like queues or stacks or anything like that, in other languages, the list in Python serves like basically the same functionality. And all a list is, and the way you define a list, I'll just call this one array, is these two brackets. And you can fill comma separated in these two brackets basically anything you want. So it can be 1, 2, 3, it can be even, you can mix it up, strings A, B, C, and so on. And that can be used to store all sorts of data. Now, you can store related data, you can store unrelated data in lists. I would generally recommend storing related data in lists, but there may be circumstances, again, in which it's necessary to store unrelated data. So yeah, here's some cool things you can do in lists. Does anyone know how to iterate through a list?
You use a for loop?
Use a for loop, that's absolutely right. So we can do something, there are actually a couple ways you can iterate through a list. So we can iterate by index. So for I in range, range of the length. So this is saying range of the length of the list. So the len function will give us the length of the list. So this for loop right here will give us the indices for each list element. 0.
Hey, question on that. With the length of, this zero indexing thing is new to me. With the length of the array, wouldn't that be like 6, and then wouldn't that print up till 5?
Sure. So the length of this array would be 6. And then, so if we think, okay, len of our array is, we can even print it actually. So it would be 6. So because it is 0 indexed, let's see. Oh. Right. So the length of our array is 6. And if we print everything in range 6 in Python, what it'll do is it'll start at index 0 and then print the next 6 numbers. So it'll be 0, 1, 2, 3, 4, and then 5. You're right. It'll end on 5. But that's the thing. In Python, everything is 0 indexed. So even the lists are 0 indexed.
Oh, so like, is the 0th element of array 1?
Exactly.
I see.
It's exactly true. So if, and I can actually write this underneath this, I'll just make like another weird index list. So these are the corresponding indices. There's definitely a better way I can do this, but I can't think of it right now. So, oh my goodness, okay. Just wanted to line up. Right, so these are the corresponding indices for each of these array elements. And the way that we can access them by index is pretty cool, or pretty simple. It's just array of our index, which is I. And if we print that, run this, for I in range when array, oh. Then it'll print all the elements of our list. So that's pretty cool. Another really cool thing that's unique about Python is we actually don't even need the iterator I to do this. We can literally say for val or any, this is like a placeholder variable. It can be any name, for val, for num, for x in array. So we don't even need the range function. We can just print x and it'll do the exact same thing. Oh my goodness. So you can just say for x in list, for, and so on. So that's kind of how you use lists in terms of this is what they are, this is how to, access them. And one other cool thing that could be super useful when you're working with lists is, all right, we know how to iterate by index, right? Which is for I in the range of the length of the list. And we know how to iterate by value, which is for x or for value in the list. Now, it might be helpful in some circumstances to iterate by both. Yeah, I can talk about list comprehensions. So and this is a cool trick that you can use. It's actually super helpful when you want to deal with both the value that you're iterating through and the index of that value. So there are a lot of times when you care about, both the value and the index of the value. And in Python, that syntax can look like for I, which is usually denotes index value, and it's enumerate, I believe. I hope this is Python 3. Print. Bad feeling this won't work. Oh, all right. And what this does, and this is actually a good way to compare the index and the value of the list, right? We can print them all. So that's super cool. Another interesting and important thing about lists in Python is that lists are mutable. So this container here, it doesn't have to stay that way. So let's say we start out with an empty container for array. And that's all we have. Now, how could we maybe fill up this container? So, question for the chat. How would I fill up this container with all the numbers 1 through 10? Or actually, we kind of did that. Maybe all the numbers, I don't know, 5 through 10. For sure. So I would use the append function. And what append does is it just sort of adds an element at the end of a list. So we can say for I, if we want to do 5 through 10, we just have to do in range 5. Range 5, what will that give us? It'll give us 0, 1, 2, 3, 4. I guess if it's 5 through 10 inclusive, we actually want to do range 6, if that makes sense. And then we can append I plus 5. And we can print our array. Making sure that I'm not running too low on time. Yeah, we're fine. All right, and that'll give us numbers 5 through 10. So the append function is super important. You can add from a list, or you can add to a list. There are also ways you can pop from a list, add at a certain index of a list, and so on. I won't go over all the different functions you can do on a list, but they're super useful in terms of having a mutable container. So that's a container that you can really easily change and access every index very quickly. So that's the power of lists in Python. And yeah, I'll actually cover list comprehensions briefly. So let's say we want this, but we want to be fancy because we're in Python, and like, why would you, if you're in Python, you should be able to do things in one line, right? So let's say we want to put in like 2, 4, 6, and 8 into our list, but we want to do this in one line. Does anyone know how we might accomplish something like that? Or maybe 0, 2, 4, 6, and 8. That'll make it easier. A for loop. Okay. Sure. We can use a for loop, but if we want to be fancy and use, one line to kind of populate our list, we can do something like this. We can do a for loop kind of within a list declaration, which is called a list comprehension. So what this is saying is, we'll call our list name doubles. Doubles is equal to 2 times I or 2 times each value, each index value for all of our I's in range 4. So working backwards, we know range 4 gives us 0, 1, 2, 3. So I's will be 0, 1, 2, 3. 2 times I's will be 0, 2, 4, 6. And let's print doubles and see if this works. All right, that's list comprehensions. Okay. Yeah, so these are lists in Python. We covered loops, looping through lists, functions. The next part is imports. We added values to lists, retrieved values. Cool. Looped through them. Importing. Right. So one thing we can do, and one thing that's super important in Python, and what makes it so useful, is that Python has a lot of packages that are meant to help people. And these packages, especially with regards to data science and machine learning, have tons of cool pre-built features that you can use that make your life a lot easier. And to access these packages, all we need to do is import package name. So there are a lot of different things that you can import. In data science, it's really common to import NumPy, import pandas. These are really common modules that we use in data science. But let's import something else. So they want us to import returns. I don't know about that. Let's import math. So actually, I was wrong. Let's import returns. Okay, and okay. All right, that's kind of cool, I guess. Return full name. So returns will, I guess, do a function call on that. That's crazy. Oh yeah, we'll actually need this later. So I lied. We're importing random. So the random module will allow us to produce random numbers, which can be pretty useful in certain contexts. And what these imports do is they import that module, and that module is now an object that you can call. So if I wanted to produce random numbers, then I would say something like that object like the module object dot function call, whatever it is to produce random numbers. So what that means is I can do something like this. If I wanted to print random numbers between 1 and 10. So this is this randint function. If you look in the documentation for random, like you just look up Python random module, you'll find that this randint function will return random integers inside a given range. So what I'm doing is I'm calling the randint function on the random module that I've just imported, if that makes sense. Making sure we got the chat, a module object, right. So a module object is essentially something, it's the thing that is imported. So, and we're not going to cover classes just now, but a given module will have a ton of associated functions with it that will let you, use that module's functions. So, for example, if you wanted to do a square root function, and Python doesn't actually have a built-in square root function. So you're thinking to yourself, how am I going to do a square root? There's actually a module you can import called math. And math contains with it a bunch of functions that Python doesn't have built in. So we can, if we wanted to take the square root of 4, we can print math.square root of 4. And that will, allow us to do this. So essentially a module object is a collection of functions that you can use to call on various things. It's like importing a bunch of built-in functions, so now you don't have to write them yourself, if that makes sense. Right. Okay, just checking time. So another interesting thing and cool thing you can do with modules is you don't have to import them as they are. Some module names are like really horrific and they're super long, and for every call to a module, you don't want to like say, I mean, it's not so bad with this one, but if it's like that, you wouldn't want to type that every time. So one thing you can do is import it as a different name. So I can import math as m. And now instead of calling math, I can call m.square root. And that'll give me the same value. So for m.square root of 4, let's just check that this works. Oh. and it'll give us 2. So these are just some basic things that we can do with imports. Yeah, and just remember, I guess, the random module for earlier, because we might need it for the next PY file that we'll be visiting this now. All right. And finally, what maybe we can do is look at our challenge.py and give that a shot. So if you can open up challenge.py, we want to produce 10 lists of random numbers. The first one will have 0 items. Second one will have 1 item. Third, 2 items, and so on. And it should all look something like this. So this is just, again, this isn't like, you don't have to do it. It's not like I'm not going to make you do anything. Like I wouldn't want to do it, but you know, you can do it. And yeah, if you have any questions, fire away. Okay. So I guess I'll give you all some time to just chew on that challenge.py thing. And for those of you who are just starting Python, like I remember when I first started Python and just programming in general, like I didn't think I wanted to do programming. I was not going to be CS going into, you know, college. I had no idea what I wanted to do. It took me like a long time it took a while to like learn things properly, if that makes sense. Like I kind of didn't sort of go over things the way I should have in the very beginning. And I paid for that later. So if you're, you know, where I was and you're just starting, don't know what's going on, like feel free to talk to me. I'm just going to be in Discord, just kind of hanging out. And I can help people get set up if like, you know, they don't know how to, you know, install Python or they haven't worked with it at all. If they need to configure like your IDE, I can help people with that and so on. Yeah. Not gonna lie, I still have problems like configuring my environment, getting that stuff to work out. But yeah, I'm curious if anyone has any solutions to. Right, okay. Math in the challenge script. Right, so we're going to need to combine everything that we have. So maybe I can start writing this actually. Maybe, who knows if I can do the challenge. I haven't actually. Okay, so we want 10 lists of random numbers, right? So the first list will have 0 items, second will have 1 and 2 and so on. So you're right, we will need to import random as our module because we're going to be generating random numbers. And remember that we can generate random numbers in a certain range with our random.randint function. And then that will give us a range of numbers, right? Now, one thing I maybe should have covered in loops is that you can nest loops. So you can put a loop within a loop. And if we want to produce 10 different, 10 different lists, and each list should be a different size, it might be a clue that we would need to nest those loops together. Right, yeah. So for every file, you will need to import, a different import statement for each file. You can actually import a file into your, this is cool. So if I wanted to say, if I defined a function in like functions.py called say hello, and let's say I want access to say hello, I can actually import functions. Oh, well, this is in a comment, so this won't do anything. Let's see. Maybe this glitch might not support it, so no promises. Okay, well, I don't think glitch supports it. Maybe I need functions.py. I'm curious. But just know that this is the feature you can use in other things. All right, so glitch doesn't support it, but you can import other Python files into your current files. But yeah, maybe I can give this a shot. All right, so we want 10 lists, and each list has to grow 1 in size, and they should all be filled with random numbers between 0 and 100. So we know that our outer for loop will iterate 10 times, right? Because we want 10 different lists. So for I in range 10 will always give you 10 things. It'll just give you 0, 1, 2, 3, all the way to 9, but it'll give you 10 things. And we want to create a list. And now this is the tricky part. So we want to create here. Let's see this. Print I. So we should notice that the index can maybe help us in determine the size list that we want to create, right? So our first list should be size 0. Our second list should be size 1, 2 and 3, and so on. And if we print out our indices, then it does look like those indices actually represent the size of each level that we should be printing. So we can say something like this. For j, and j is just another iterator. I and j are often used together in range I. So we're kind of using the iterators together to produce this kind of nested structure that we want, right? This means that when I is 0, so for the first time, the j will iterate 0 times. When I is 1, j will iterate 1 times, 2 times, and then so on. Finally, we can use our, list, our append feature. So for each iteration on the outside, we should create a new array, right? And I hope y'all are following. This actually isn't a super trivial problem. I would not know how to do this if I was when I started. Definitely not. I mean, I'm not even sure if this is correct. Okay. And then finally, for each j and I, we want to append a random value from 0 to 100. We know we can do that by calling random.randint. This will give us a random value from 0 to 100. We append it to our array. Finally, after we've created it, we can print that array. And still in this for loop. So let's see if this works. Okay, so this looks decent. And does everyone understand kind of the thought process that went into that, right? So we want to create 10 different arrays. And the arrays, if we notice, they're the size of the index that we printed out. So then we can do a second nested for loop on this index. And then we use the append function and the module that we imported to produce a random number.
So I have a quick question.
For sure.
I've mostly used C++. How does Python determine where your new lines are formed?
Oh, right, yeah. So that's a good question. So in Python, the print function will give a new line automatically. So if you notice, I'm printing everything out on the console in a new line, right? So the print function automatically returns a new line. I think in Python 3, it supports that if I do something like this, this will tell the interpreter to give no new line if I do end equals. But in Python, there is automatically a new line formed. And for those of you who don't know, a new line character is essentially what is produced when you press enter or return on your keyboard. And it actually has a string representation, something like this. So in quotes, if you do \n, that's a new line. So if I were to do something like, hello, people. Am I crazy? No, I'm not crazy.
That's right.
Yeah, okay. Oh, I never printed that. Okay, and it'll print hello people because that is an enter character. So just something nifty that you can use. All right, so we're probably gonna wrap up kind of soon, and I actually maybe should have left some more time for questions. Whoops. Okay. Challenge, we can skip the quiz, we're fine. But yeah, I think we're good on in terms of the meta level stuff. I'm curious if y'all have questions about Python in general.
Yeah, I had a quick question. So I'm kind of in the position that you were describing. So did you say you went to A&M or where did you go?
Yeah, so I'm at A&M right now, actually.
Okay, so I'm I'm in engineering 102 right now, with the whole Python and all that stuff. And I just finished my first test, and I'm kind of at the point where I understand like the basics, but once I start getting into, for example, nested for loop or a little bit more of difficult problems, I kind of lose track of what I'm supposed to do. What did you do in that position when you were there, like to just break through that and learn? Like, I guess what I struggle with is learning the English language description of the code that I'm writing, if that makes sense.
Sure. Yeah, so I'm not gonna lie, it definitely took practice, right? In terms of, so for me too, engineering 102 was like my introduction to Python. And it took practicing those types of problems to kind of see, patterns. Like when I see all those lists together, I understand like, okay, it's a nested for loop. I guess in terms of tips I can give to sort of, develop that understanding, try and do there are a lot of resources, maybe not LeetCode, but there are a lot of resources for like small, almost puzzles in Python, right? Or in any programming language that you can complete, kind of like challenge.py. And maybe I will link some later in the Discord. But essentially, if you like doing puzzles, which I just like doing puzzles, and you start with the easier puzzles and then you work your way up, I find that it's a lot more approachable to sort of develop that, intuition for problem. Another thing that helps is kind of playing around in your IDE. So using, a bunch of nested for loops, seeing how to print maybe like an array or print cool shapes like print a diamond, stuff like that. If anyone else has any other questions,
Thank you.
let's definitely take them. And if not, this is what I recommend for getting started in Python and data science, especially. I would definitely recommend Visual Studio Code for your IDE. There are a lot of other IDEs that you can install for handling code. The reason, especially for beginners, I recommend VS Code is it has a bunch of super helpful extensions that you can search. And I could just be like, give me, oh wait, this is the wrong thing. Right. I can look up, Python extensions that will help autocomplete my code or debug. So I would recommend Visual Studio Code to install, and Anaconda, which is this huge collection of packages about data science and stuff like that. Right. Yeah, that's a good point, Hannah. Any other questions? in the comments. Does anyone feel like overwhelmed or something right now? You can tell me. But yeah, when I started, I feel like the curve for programming for me kind of went like super flat, and then it like spiked and it leveled out. So, you know, it might feel super slow in the beginning, but you know, you'll get there before you know where you want to be.
Okay. I feel the same way because like whenever I look at a code, I just look at it and I'm like, okay, I understand what to do, but like when I construct it, I don't understand the logic. So
Right.
then like once I like look it up or something, I'm like, oh, this is what I did different for my code. And then like I can't do it by myself. I always have to like look at something else. So I was just like, I don't know. Do you have any advice for like overcoming that? I know like practice.
Yeah, that was a problem for me too, is that especially in programming, right? It's super easy to kind of, because there's so many open source, free available resources and people who, you know, are great at explaining things and problem solving, but sometimes it can be a crutch. And I know it definitely was for me, right? When it was just so easy to look at, you know, stuff on Stack Overflow. It's like, oh, this is how they did it. But, and this isn't necessarily a fun answer, but I think like the biggest value add of just computer science in general is like when you just are racking your brain trying to debug a problem, and you try like, you kind of have to try all the things that you think might be wrong. Accelerating the speed at which you try things is like a really important skill that I think CS develops. So I'm not telling you to like, you know, destroy yourself over this hard problem and never look anything up. Like, of course not. But I would say that maybe give yourself like, set yourself a certain amount of time that you're willing to spend on a problem. And maybe before looking something up, try consulting someone. So that way, like a peer or someone else, so you can both think through the problem together, because that experience is definitely helpful. Even if you're wrong, like even if you're wrong in the beginning, it can be helpful to just get practice being wrong, if that makes sense.
Yeah, thanks. That helps.
All right, well, that's how much time we have. I'm going to be in the Discord. Have a great happy hacking, something like that. All right, see y'all.